Starting a new chapter, lesson 8.1, and what we're going to do in this whole chapter is we're going to work with quadratic functions. But today what we're going to learn how to do is we're going to learn some characteristics of them, learn how to identify quadratic functions. We already know what quadratic means. Quadratic means we have a polynomial of degree 2. So a quadratic function is any function, so any equation that can be written in the standard form y equals, and here's our polynomial, ax squared plus bx plus c. So that's the standard form for a quadratic function where a cannot equal 0. If a was equal to 0, 0 times x squared would be 0. X squared would be gone. It would no longer be quadratic. It would become linear. Okay, so now let's look at some of the things that are going to be important for you to start getting a handle on. The basic one, the most basic one, the one we kind of go off of, is called the parent function. Every function has a family, and in that family, there's a parent function. And here's the parent function. It's very basic. Y equals x squared. It only has the x squared term, doesn't have the x term, doesn't have the c term. So when we talk about the parent function y equals x squared, the a value, how many x squareds are there? The a is equal to 1. The b, because there are no x's, that means that b had to be equal to 0. And because there is no constant, that means c was 0 also. Because when you multiply x times 0, you'd have 0x, they'd be gone. When you add 0, that doesn't change anything, so that can be dropped off also. So our parent quadratic function is pretty basic, y equals x squared. When we talk about the graph of one, of a quadratic function, it's a smooth curve. It's not a line, we can't use a straight edge for it, it's kind of a funny word, called a parabola. It kind of looks like parabola, but it's parabola. And I have some drawn here. I say it opens either up, and notice what it is, it's U-shaped. So it either opens up or it opens down. So we have a U opening up or a U opening down. And what controls whether it's going to open up or open down is what's the a value. So your a value is going to control it. So remember, that's the number that x squared is being multiplied by. So when a is greater than 0, what numbers are greater than 0? The positive ones. So when a is positive, it opens up. So if you have a positive number of x squareds, you know that your parabola will open up. When a is less than 0, what numbers are less than 0? The negative ones. So when a is negative, it's going to open down. So when you have a negative number of x squared, you can count on the parabola being an upside down u, one that is opening down. Okay, in this u, it's going either, it starts and it's going down and then all of a sudden it makes a turn and it goes back up again. Or if it's going, so this is what I was just talking about, it's going down and then all of a sudden it makes a turn and it's going back up again. Or it might be climbing first and then it makes a turn and it goes down again. And it changes direction at a point. So there's a point where it kind of, changes that direction. And that is called a vertex. Okay, so when it changes direction, there's this point, and it has an xy value, it's an ordered pair, it's a point on the graph, and we call that the vertex. So when the parabola opens up, notice I have a picture of it here, the y value of the vertex, so we have this ordered pair here. Remember, it's got an x and it's got a y. That y value is called because it's the lowest y value on all the points on that curve, we call it a minimum. So this, the lowest y value that you get out of any points on that curve, so we call it a minimum. When the parabola opens down, so here's our parabola opening down, there's our vertex with that x, y value. That would be the time when the y value doesn't get any higher than that. That's the largest y value that you're going to get of all the points on that curve. So that one's called a maximum. So when the parabola opens down, the y value of the vertex is called a maximum. So they'll refer to the minimum and the maximum of a quadratic function, and we have to know what they're talking about. Okay, the other thing that I want you to put in your skill bank, it has an imaginary line that divides the parabola into two symmetric halves, called an axis of symmetry. So this imaginary line, it's not really drawn there, but we could draw it. It would divide that parabola into two identical halves. One could fold right over on top of the other. And that imaginary line is typically drawn as a dotted line, as you see in my diagrams there. And we want to know that that is called, so let's put this right here, that dotted line, that's the axis that I'm talking about, axis of symmetry. Okay? The axis of symmetry, and there it is for that one. Those are your axes. That's the axis of symmetry for each of those. And notice, what does it go through? It's going through that vertex we just talked about. So the axis of symmetry cuts through the vertex. It would cut that parabola into two equal halves. And so we have to have an understanding of, if they talk about the axis of symmetry, what are they referring to? Okay, let's go to the back side and do some more talking about how can you identify if a function is quadratic. So in other words, we don't have the graph for it, we just have the equation. How can we decide if it's quadratic when they give it to us as an equation? Well, first thing you want to do is you want to get that y alone, because remember, we need it in y equals form, so we can tell if that other side looks like it's a quadratic polynomial or not. And then we're going to write the other side in standard form. We know how to write a polynomial in standard form. That's what we learned first semester. And then we're going to decide if it is of the y equals ax squared plus bx plus c form, our quadratic form. And remember, it really only has to have the y and the x squares. It can have some x's and it can have a c, but it has to have the ax squares. Okay, so let's do some practice here. Number one, we're going to decide if this is a quadratic function or not. So we need y alone, first of all. So we're going to, y is over here, so we need to subtract 6x to get it alone. So we have just y now on the left side. We have negative 14, subtract 6x. Well, I know your brain's already going here. We're going to rename that as add the opposite. And now we're going to put that right side in standard form as it's set up. It says write the other side in standard form was the second step. So to get it in standard form, y equals, we're going to have the negative 6x trade places with the negative 14. And then we're going to decide, is that of the y equals ax squared plus bx plus c form? Well, it's got the bx, it's got the c, but what does it absolutely have to have? It's got to have these ax squareds, and it does not, so we're going to say not a quadratic function. What do you think a would have been equal to make those x squareds go away. Not a quadratic function. What do you suppose a was equal to? 0, because 0 times x squared made them go away. Not a quadratic function. A is equal to 0. Remember back on the front side we said where a cannot be equal to 0. Okay? So, let's move on to our next one here. 2x squared plus y equals 3x minus 1. Well, the y is over here, so we'll get that those x squareds moved out of the way. We can subtract 2x squared from both sides. Okay, now we'll have y by itself, and then let's just write it in the order it is. 3x, take away 1, and then we decided we also need to subtract 2x squared from this side. Yeah, I know, you're probably already a jump ahead of me. You have changed those subtractions to add the opposite, because you're good at that. And now the next step says get the right side, the other side, in standard form. So we're going to put 3x plus negative 1 plus negative 2x squared in standard form. Remember, standard form is the variable term with the highest exponent gets to be first. So negative 2x squared gets to be first, plus 3x would be the next one, because that's the next highest exponent on x, and the constant is last. So how do you feel about that? Think that's quadratic? We have an x squared term, we have an x term, we have a c term. I think it looks quadratic. So we're going to say, is a quadratic function, and when it is quadratic, guess what we're going to do? Just like we did for factoring, we're going to say a equals, b equals, c equals. So our a value is negative 2. How many x squareds are there? Our b value is 3. How many x's are there? And our c value, or our constant, is negative 1. So you'll be doing some of that in your homework too. So being able to take a function, rearrange it, get it in so it's y by itself, and then decide if the other side, when it is written in standard form, is of the form y equals ax squared plus bx plus c, where for sure you have to have the ax squares. Okay, well then the last thing we're gonna do together here is, what if they give you a table of values, or in other words, a table of ordered pairs, a set of ordered pairs, and they want you to tell if it represents a quadratic function. So we're not going to graph it. We are going to be graphing, but today we're like, you know what? Don't want to graph this. How can I tell if it would be a U-shaped graph just from the table? Here's what we're going to look for. We're going to look for a second common difference. Second common difference we're going to look for a second common difference in y. Notice it's the y's that we're going to talk about. When there's a constant change in x. So we still have to have a constant change in x, but so that's the first thing we'll check out. Do we have a constant change in x? When you go from negative 4 to negative 3, the x just went up 1. Negative 3 to negative 2, the x went up 1. Negative 2 to negative 1, the x went up 1. Negative 1 to 0, the x went up 1. There's our constant change in x. It went up 1. So it's a positive 1. X has a constant change of positive 1. So when x has a constant change, now we can go and look for that second common difference. Well, the first time that we check to see what's happening in the y's, that's called the first difference. So to get from 39 to 18, what do we have to do? 39, take away 18, or in other words, it went down, and it went down 21. To go from 18 to 3, what happens? We go down, and we go down 15. To go from 3 to negative 6, it's getting smaller, so we're going down again. The distance between 3 and negative 6 is 9, so negative 9. And the distance between negative 6 and negative 9, we're going down again, 3. So that's what we call our first difference. What's the change in the y's as you go from one y to the following y? Okay, well, is that a common difference? It's not. Negative 21, negative 15, negative 9, negative 3, they're not all the same. So if it had been, I don't know if you remember this back, all the way back from chapter 4, last year, if it would have been a common difference now in this first difference, we would stop and say this is a linear function. But since it's not linear, we're going to go on and we're going to check now to see if it's quadratic. So now we have only 3 differences to find, from 21 to negative 15, from negative 15 to negative 9, and from negative 9 to negative 3. So to get from negative 21 to negative 15, this time we're actually going up, and the distance between those two on the number line is 6 units. So what's the difference between them? How much distance is there between them on the number line? Now we're going to go from negative 15 to negative 9. Again, it's going up. We're going to the right on the number line, so that's positive. And the distance between negative 15 and negative 9 is 6. And our last difference, negative 9 to negative 3. So again, we're going right on the number line from negative 9 to negative 3. The distance between those two is 6. This is what we call our second difference in y. So we just found the second difference in the y values. So that second row here now, I want you to identify that as the second difference in y. And now, remember what it said. It says we're going to look for a common second difference in y when there's a constant change in x. So we have a common second difference, so we're going to say is a quadratic function. So if we graphed this, we could count on a U-shaped graph, a parabola, and because it has we'll use the abbreviation for second here, it has a second common difference. Okay, and our work shows what that common second difference is. So when we have a table of ordered pairs without graphing them, we can tell whether it would give us a U-shaped graph. And we don't have an equation. We have no idea if this U-shaped graph would open up or it would open down. But we do know that it's quadratic. Okay, so these are the kinds of things that you're going to need to work on in your homework. So make sure you're referring to your notes, and we'll see you tomorrow.